Okay, welcome to the seminar. Today we are going to talk about software development. We are going to look at the history of software development, predict the future in the wave that we are currently in. That's the AI wave. I'm Pranav Pandey. I'm going to be your host. I'm going to present this, and I hope you learn something today. So, what is software development? So, if you think about it, software development is nothing but the art of translating the business problem to the computer or explaining the business problem to the computer so the computer can solve it. It's not actually writing code or anything. It's anything we do or anything a business does is solving problems. And software development is translating that business problem to a computer so that the computer can solve it. And who is a software developer? A person who translates that business problem to a machine so that it can solve it. So this is a simple map of where the software developer fits in. You have a business problem and you have a software developer, and then it converts that business problem to a machine code so that machine can execute it. But this is very simple, right? For a complex problem like how do you design a calculator or how do you design anything complex, a website, this is very, very simple. So what people do, or over time, what people have done is create abstractions around this simple flow. And they come up with something like this. This is what you can say a stack of software development is. So let's look at it. Like first you have the business problem, the problem you actually want to solve. This is your client. This is the person who requires the software. Then you have business requirement generation, which is done by business analyst, which actually asks the client to actually articulate what is the problem, because sometimes the client does not know what is exact problem, and they kind of solidify what the problem is. And then you have the product manager. What does the product manager do? It kind of create use cases around the business problem. So kind of create little problems from that big problem. So segregating, or you can say dissecting the problem into smaller problems so individual problems can be solved. Then you have an architect or a tech lead or a PM. So what does an architect, tech lead, or a PM does? It creates domains or it creates abstractions around those use cases. And when you create abstraction around those use cases, you kind of create a model, or you kind of create a mental model of that problem, kind of a world of that problem. And then you have software developers who create lower level design from that domain design, and then write the programming languages. Then that programming languages are actually compiled into assembly, which are actually compiled into machine readable code, which a machine looks at and actually executes. And that's how your software development stack is actually executed. For a problem that is too complex, right? Something like you want to deliver a pizza in 10 minutes, or you want to deliver a grocery in 10 minutes. How do you create a software, or how do you create a system for it? It is very, very hard, right? And it is so hard that there doesn't exist a solution. That's why software is always developed, but a flyover is always built. And for these type of problems, every problem is a new problem. There's no defined solution for it. We have a system which is what we call the agile development or iterative development, where people don't define a problem, but they say, okay, let's, the whole process is to define the problem better. So over time, our problem becomes better and better. And so we solve it better and better. And that's how our system becomes better and better. This is the whole idea behind agile development, where this is how you see software development life cycle is. This is uh, taken from a book which is called Software Development. And this is where that book concludes that this is the current state of software development. So if you see this, you will see a loop. where you first create a first prototype, then evaluate that prototype and evolve the system. And this loops goes again and again and again. So your software keeps developing again and again. This end project state is never actually reached. And this is how the state of software development currently lies. And there are multiple people who contribute to this, who have definite designation in that whole software development stack. And the first designation is a problem spotter, the person who actually spots the problem or who identifies the new problem or who defines the problem better. We talked about, right? The whole process is to define the problem better and better. So these are the people who defines that problem better and better as soon as you solve it. You can take an example of, okay, I want to deliver in a 10 minute. So, okay, I have a map. I look at where I need to be, have my dark store, and then I just say to my delivery agent, okay, this is the location you have to go in. You can follow this route and you can go there. But then new problems come in that there is traffic, or how do you handle it, or how do you identify where to actually go and deliver it, because you have to translate that address to a location, right? So this is how a problem of delivering a product in 10 minutes got uh, defined more and more. And these people are actually who does it. First, you have the product manager. A product manager looks at the product, looks at the space of the problem and asks question, and then defines sub problems. Then you have a CSM solution. These are solution engineers who actually work with your client. So you have a person. This happens more in a enterprise use case where you have a person who works with your client very, very closely, and in working with that client in understanding his problem, because a client always needs more features, more things that the software can do. He identifies these problems. These are called solution engineers. Then you have competitive researchers who actually analyze other people or other you can say your competitors, who say, okay, those people are doing that, let we can also do that, and all those things. Then you have solution builders. A product manager is also a solution builder, because identifying a problem and finding a solution is both managed by a product manager. Then you have a tech lead. So a tech lead works very closely with the product manager, and he advises what are the limitations of a computer is, because he actually knows the whole stack very well, and he can advise him, okay, this problem can be solved this way or this problem cannot be solved. And then you have the software developers who gets instruction from a tech lead to actually write that code that is like going to be executed in the uh, machine that is going to solve that problem. And then you have system improvers. These are also people who finds more problems or who take care of running that whole system, like your DevOps, SREs, or business analysts. So with the AI and with this, not with the AI, with increase in complexity of problems, what happened is what I call a junior developer trap. What that trap is that, okay, this is the specification, go write code for it. And this is what most of the industry right now is has defined a software developer to be. But the software developer, if you look at the first slide, right, was never this, right? He was the, he was the person who was supposed to understand the business problem and translate it to the machine code. But now he's just a very, very small part of it who just got instructed and writes the code. He does not understand the problems fully, or you can say some people do. I'm not saying that software development is entirely away from what it originally thought to be, but a junior developer, what I call a junior developer, is like that. He just writes code. And this is how actually growth in software development is seen as. What is seen as that you start as a junior developer and you start understanding the computer first. So basically, you start uh, from this top of your stack. You understand the computer, bytecode, assembly, programming language, and you are supposed to go down the stack. So you are able to understand the business. And because you're coming from the top stack, now you understand how to solve it. And then you apply that whole logic to solve the business problem. And then that is the transition that happens from a junior developer to a tech lead. That is the growth trajectory almost all of the people go through. They first learn the computer, they first learn to how computer works, how these things are evolved and all those things, whichever you call it. And then they go into the problem space. And that is where you become a tech lead. So let's look at history to see how industry has changed with some of the changes that we have seen in software development. By the way, there's a big, you can say, thing that people say that this industry changes every 10 years. Every 10 years, something new happens, and the industry has to rethink how it works or how people work. So first thing we are going to look at is invention of compilers. So earlier what used to happen is somebody has to write the assembly code, or you can say somebody has to write the zeros and ones itself, and then the machine was able to execute it, right? Then compilers were invented. So what compilers did was create an abstraction on top of those zeros and ones so people can move to solve the problem from actually writing the zeros and ones. They can move from memory management. They can move from maintaining the stack. They can move from maintaining the registers or manipulating the register. So as more and more, so if you look at this stack, right? So we started allocating the bytecode and translating to the bytecode more and more to the machines. Okay, you translate it. I don't want to write zeros and ones myself, right? I will just write a very high level language that will translate to zeros and ones. So my time is kind of saved. And so when my time is saved, what will I do? I will start looking at the business problem, or I will start spending more time with the business problem and start solving it better and better. What happened with this is we started designing bigger and bigger systems which can solve more and more complex problems. And the second thing I want to show is a DevOps abstraction that we created. So earlier was used to happen is there were two teams that used to work in one team that develops the software and the second team that maintains it or that runs it. But what used to happen is people who are running it always complains about the software is not very well built and all those things, because running a system has very different problems than actually building a system. You have to solve a very different set of problems. And because people who were building the system and who were running the system were two completely different people, uh, there was a layer. And because of it, the system was not able to run very well. It was very hard to run it. And the solution for this was give the same people responsibility to run the system who are actually developing it. And that was the whole DevOps, uh, you can say, wave that happened over time. And that solved a lot of things, by the way. So let's look at what is happening right now. Okay. So the death of the syntax translator, you can say, the death of the junior developer. So what AI agents are able to do is they are able to do the exact thing the junior developer was assigned to translate the code. And now you also see the openings. There is no opening for a junior developer. There is no opening for just a person who can write code, right? The bar is higher. And the future of software development is that, because that has always happened. You have to move up the stack. You have to understand the problem more and more and try to solve it. That is what you also become when you become a tech lead. You get involved with the business. So you have to move up the stack. This is also what a new term is happening, being coined, that is called forward deploy developer. Developer. What that developer does is that works very closely with the client. So the whole layer of a product manager is getting removed, and a software developer is taking the role of a product manager. So if you look at the stack, the software developer now sits here, uh, at the product manager, and this all things will be taken up by a single individual. And what people are expecting from this is now that we will be able to solve bigger and bigger problems, and we are able to create better and better solutions, right? The industry is not going to go away, right? The impact of the industry is going to be massive in the coming future. Like, if you look at the software, the penetration of software in India is still at 5%. Right? There's so many things that we can automate. The opportunity is endless. So how do you prepare for this future, right? So first, try to become a tech lead. A tech lead is a person who has all the knowledge of a software system. So basically, skill up. Don't be just a coder. Be a person who designs a system, who understands how every piece of computer works. Then also, you have to own the product vision. You have to understand the product vision. You have to give the product a vision, what product managers are able to do. And the third thing is that you have to start building projects. And that's the only way I see where you can actually learn all these things, right? Because when you develop a project from ground up, you will take up all the roles which we have defined here, from identifying the problems to actually writing the code. And that skill will never go away, right? Because somebody has to run the AI agent also, right? Somebody has to explain to the AI agent what to do. And a person who understands computer very well will definitely be able to convey to him very well what the agent has to do, or what this coding agents have to do. So to do that, we are announcing a hackathon. This is called Uttarakhand Innovation and Solution Hackathon. It starts from May 1st, and it ends on May 16th and 17th with an in-person demo day. And we have decided of prizes worth 50,000 rupees. The the topic for this hackathon is to create solutions for Uttarakhand, anything to solve the problems of Uttarakhand or anything under the Uttarakhand domain. You can join our challenge to register for this, and that's it. Cool. Thank you, people. Uh, we'll meet again. Bye bye.
Thank you, sir.